It's Sunday, April 10th, and for a change of routine, I wanted to do a science experiment today. Back in 1978, I was the lead nuclear engineer on a project in upstate New York, and the company I worked for at that time bought the last nuclear reactor that was ever bought during the first nuclear renaissance. The project was later canceled, but as part of that, one of the things that the vendor gave me, who we bought the reactor from, was a piece of a nuclear fuel rod. This is a nuclear fuel rod. This is zircaloy, and it's the element that's inside of the Fukushima reactors. Now these are about 12 feet tall, and there's thousands of them inside the Fukushima reactor. This is a simulated pellet of uranium. Now it's not the real thing, it's plastic. If it were the real thing and had been operating in Fukushima, I'd be dead by now. But these pellets go into these fuel rods, and over 4 years create a lot of heat. When the reactor shuts down, they remain hot. So what I wanted to do today is to show you what happens to zircaloy when it gets hot, as it happened when the water stopped in the Fukushima reactors. Okay, we've got our experiment set up here, and this is what we plan to achieve. Here's that fuel. I took the plastic out, and we're going to heat it with a torch to simulate the heat that's coming out of the inside. Then we're going to spray water on the outside, and you'll see steam coming off, which represents the steam that's coming out of Fukushima right now. Now in that steam is also hydrogen gas, because the water hits the zircaloy and creates not just steam but hydrogen gas. This is my friend Jim. He's a great neighbor, and he's going to be the acetylene torch person. Okay, the zircaloy is cherry red, and now I'm going to spray it with water as if it were getting some water in the bottom of the reactor. What we just did was we oxidized the zirconium. You can see it's a different color now. The metal that was quite strong becomes very, very brittle. And we were just able to break pieces right off the end of it. Well, inside the nuclear reactor, it ran at that temperature for 7 to 12 hours. The fuel got brittle, and all those nuclear pellets then were allowed to fall out. We just created what went on inside the Fukushima reactor. Those rods glowed that hot for 12 hours or more. Now what happens is we've created an oxide. This is zirc oxide now, and it's very, very brittle. I think you can see these sharp edges. So the fuel that was inside is now free to fall out and onto the bed of the nuclear reactor and begin to melt through, as is happening right now in Unit 2 at least, and perhaps Unit 3 as well. Well, thank you for watching. Arnie Gundersen, Fairwinds, and we'll do another video in a couple days. Thank you very much.